Hi everyone, my name is Suram and I welcome you all to my YouTube channel. In today's video we are going to discuss about the last part of 7th chapter, that is of standard 9th, energy flow and practices for the conservation of resources. That is the last part we are going to discuss, and in today's video we are covering nuclear energy, is it? Then nuclear fission, uncontrolled nuclear fission, then controlled nuclear fission, is it? Then hazards of the nuclear power generation, is it? Then we have the fusion nuclear reaction, then fossil fuels, origin of the fossil fuels, is it? Fossil fuels as a non-renewable source of energy, then the uses of fossil fuels. All we are going to discuss in today's video, and it will be the last part of this chapter. Energy flow and practices for conservation of resources, that is of standard 9th. So very first is the nuclear energy. So nuclear energy is what? Nuclear energy is generated by the two methods. So basic principle is when a heavy nucleus of elements like uranium, thorium or plutonium is split, or when the lighter elements such as hydrogen or deuterium is fused to form heavy elements, means heavy element is brought back up into smaller one, and the smaller one are joined to form the larger one, is it? In such a way that the total mass of the atoms of product is less than the participating atoms, is it? So that the total mass of the product is less than that of the participating atoms, then the difference in mass is converted into energy, is it? So this energy is given by the relation E is equal to mc square, that is our famous equation, is it? E is equal to mc square, and this was first derived by Albert Einstein in 1905, is it? So where E stands for the energy, is it? And E stands for the energy released, m stands for the mass, is it? And c stands for the velocity of light in vacuum, is it? So in nuclear science, this energy is often expressed in the unit of electron volt, is it? So this energy is expressed in the electron volt, and 1 electron volt is 1.6 into 10 to the power minus 19 joule, that you are knowing already, is it? So if we consider a 1 atomic mass unit disappear in the nuclear reaction, then applying Einstein equation, the energy released in this case will be 931 mega electron volt, is it? So very first we are going to discuss about the nuclear reaction, that is a nuclear fission, is it? Nuclear fission, it is the process by which a heavy unstable nucleus like uranium-235 is broken into the two medium weight nuclei by the bombardment of a slow neutron, is it? Uranium-235 is bombarded with a slow neutron, is it? And so as to liberate more neutrons are liberated, is it? And the tremendous amount of energy is released in this nuclear reaction, is it? So uranium-235 is further divided into barium and krypton, is it? So these are further new neutrons are produced, is it? So this will bombard with these other nuclei, and this process will remain continuous, and it is a chain reaction, you can say. So during this, a large amount of energy is released, is it? So sum total of the mass produced is slightly less than the reactants, is it? So this difference in mass is converted into energy, as we have discussed already, right? Then what is the uncontrolled nuclear fission? Uncontrolled nuclear fission, that can be a bomb, you can say, is it? Uncontrolled nuclear fission. So if the process is allowed to carry on, then as we have discussed earlier, if this process remain continuous, then it is estimated that within a few seconds 10 to the power 23 atoms of uranium, is it 235, will break it to produce an enormous amount of energy. It is not one atom, it is 10 to the power 23 atoms of uranium 235 will break to produce an enormous amount of energy, is it? So which will produce a highly devastating effect, is it? So this based on this principle, this has been used to produce the bomb, is it? So which was dropped on the cities of Hiroshima and Nagasaki in 1945, is it? So these bombs have killed millions of people in a minute, is it? So this is having a very devastating effect, you can say, is it? Uncontrolled nuclear fission, is it? So this you might have heard in history also, when the bomb was thrown on Hiroshima and Nagasaki, is it? So massive damage was done. Then we have the controlled nuclear fission. We can control this nuclear fission, is it? And the nuclear power plant for the production of electricity, is it? Controlled nuclear energy. So the controlled nuclear fission is carried out at a highly compensated machine called the nuclear power reactor or the nuclear reactor, is it? So this we have already learned that during the nuclear fission, fast moving neutrons are produced. So furthermore, every one slow neutron, there are produced 3 fast moving neutrons, is it? So in this nuclear reactor we place a mass material such as boron and cadmium, which are capable of absorbing the neutrons, is it? So they are placed in such a way that amongst these fast neutrons, 2 get absorbed, thereby leaving the third fast neutron, is it? It is then slowed down by the material such as graphite, is it, or heavy water, and finally used to carry out the nuclear fission, is it? So graphite are used in this nuclear reactor as to control the reaction, you can say, and in a way we are able to control the production of slow neutrons and hence the nuclear fission, is it? So in a controlled nuclear fission, the limited amount of heat energy is produced. So this energy is utilized in raising the steam and finally turning the blades of the turbine, is it? It is used to turn the blades of the turbine, is it, for the production of electricity. So this is how the nuclear power reactor work, and we can control the nuclear fission reaction, is it? So what are the hazards of nuclear power generation? So very first is the major problem is in the nuclear power generation is storage and disposal, is it? Storage and disposal of spent fuel, which is highly radioactive, is it? So if not stored properly, it can cause an environmental contamination, is it? So which can affect the health of the millions of people, is it? Then there is a risk of accidental radioactive leak at the nuclear power plants. This you might have seen in Japan recent years, it has been leaked, is it? So third, it is very costly to set up the nuclear reactors, is it? And hence the cost of electricity operators is high, and then that is of thermal coal waste power plants, is it? So its cost is higher. Then there is a limited amount of uranium that is available, and thus nuclear energy is exhaustible source of energy, you can say, is it? Although it can produce a high amount of energy, but it is a limited source. So it is exhaustible source of, means a non-renewable source of energy. Then we have the nuclear fusion reaction, is it? What is the nuclear fusion reaction? In the core of the sun and stars, there is extreme temperature of the order of millions of degrees Celsius and extreme pressure of millions of pascals. And such a high temperature, the deuterium, is it? The deuterium and isotopes, it is one of the isotope hydrogen, fuse to form the heavy nucleus of helium, is it? Heavy nucleus of helium is formed, is it? So in this reaction and nuclear fission reaction, the mass of the product is somewhat less than the mass of the participating deuterium atoms, is it? So the difference in mass is converted into energy, is it? So thus our sun as well as stars are powered by the nuclear fission reactions. Inside the surface of inside the surface of sun, this nuclear fission reaction is going on continuously, is it? So which is forming a tremendous amount of heat. So if we would able to copy this same reaction on the earth, then we can have the unlimited amount of energy, is it, for the million years. So it is because we have abundant sources of deuterium in the form of seawater, is it? However, the controlled fusion reaction is not possible so far. So because of the extreme temperature and pressure required to initiate this reaction, that is one of the main reasons that we are not able to control this reaction, although we are able to make the hydrogen bomb, is it? So hydrogen bomb is basically the thermonuclear bomb, and it is in its core is placed an atomic bomb, is it, which is then surrounded by the material soaked in deuterium and lithium, is it? Then atomic bomb is detonated, and the temperature of the substance soaked in deuterium and lithium raises to 10⁷ Kelvin in few microseconds, is it? So this high temperature and pressure initiate the nuclear fusion with the release of devastating amount of energy, is it? So we are able to produce the damaging effect, but we are not able to use it for this useful purpose. Then we have the fossil fuels, is it? So the fuel which are present under the earth crust as remains of plants and animals, that are called the fossil fuels. So fossil fuels basically are of three types: coal, petroleum and natural gas, is it? Coal, petroleum and natural gas. So what is the origin of these fossil fuels? So how the fossil fuels are formed? So how the fossil fuels are formed in nature, it is an open to discussion. However, it is widely believed that the millions of years ago, that is about 200 million years ago, due to the certain natural calamities such as earthquakes, cyclones, storms, is it, floods, etc., a large number of animals and plants get buried under the earth, is it? So under the humid conditions and very high pressure and temperature, the earth and the bacterial decomposition in the absence of air, they gradually decomposed to form coal, petroleum or natural gas, is it, depending upon the external factors to which they are subjected, is it? So this is how this coal, petroleum and natural gas are formed millions of years ago, is it? Then fossil fuels, it is a non-renewable source of energy. Why it is called a non-renewable source? Because as we have discussed already, it is taking the millions of years to form the fossil fuels, is it? And it is taking the millions of years to renew also, right? So thus fossil fuels are very precious, so we must use them when absolutely necessary, otherwise they will be exhausted in another hundreds years, is it, or so thereby causing the unprecedented energy crisis, is it, so from which our world will never be recovered. So fossil fuels, it should be used very wisely. So it is a non-renewable source of energy. What are the uses of fossil fuels? Uses of fossil fuels, it is used for the various purposes. These days coal is extensively used in the generating of electric energy in the thermal power station, and natural gas is used in generating the thermal electricity, is it? It is also used in the household fuel and the fuel for CNG buses. Then we have the petroleum is refined into products such as petrol, diesel, kerosene, lubricating oil, it is furnace oil and the petroleum gas. So these are some uses of the fossil fuels. Then what are the importance of energy for development in India? Importance for the individual, is it? So if the energy is provided especially in the villages, then each individual can have the chance to go to do the various jobs mechanically, is it? So then they will be able to utilize the time thus saved for education, is it, or doing some fruitful activities, is it? Otherwise, over for the 70% of the Indian population lives in the village, and a very large percentage of it is illiterate, is it? So it is the most of the time is consumed in doing the various agriculture activities, etc. manually, and they are hardly left with any time, is it, to pursue the studies and the other social activities, is it. So that's why if chances are given to these people, then they can perform better, is it. So that is of importance for the individual. Then second, social importance. Once an individual gets the sufficient time, they can collectively think about improving the environment in the villages, is it. They can collectively keep their village clean, then look after the proper hygiene, is it. Then can organize the social function, which is on the whole will make their life richer, is it. Then we have the global importance. So with the availability of the energy, the educational, social and economic standard of the country will rise, is it. So this in turn will give rise to our country a status of the world power, is it, and the trade and commerce will flourish, making the country all the richer, is it. So that is our global importance of the energy development. Then what are the emerging patterns of energy consumption in India, is it. Emerging patterns of energy consumption in India. So during the last 60 years, our population has increased from 356 millions in 1951 to 1210 million in 2011, is it. So however, there has been a 20-fold increase in power consumption, is it, since 1951. So this shows that use of power of individual or society has increased manifold, is it. So individual consumption is what, in 1951 only big cities were provided with electric power, is it. So the power were consumed for lighting, running fans, is it. Other costly electrical appliances were not in reach of the ordinary citizens, is it. So why the 2001 the appliances mentioned above, is it, that is electrical appliances, costly electrical appliances have become the utility items in the big cities and are found in most of the well-to-do home, is it. So this has increased a heavy demand for the individual consumption, because we are using the various appliances for our various comforts. Then the social consumption. So the big industries in cities have a very high demand for the power. In addition to it, the power is required for providing the civic facilities. Railways use a large amount of power, trade, commerce, establishment, hotels, restaurants, then cinemas, house, etc. They are also consuming a large amount of power, is it. So in villages, maximum power is used or consumed in agriculture operations like running flour mills, etc. Thus a huge amount of power for societal consumption, which is not met by all the power generating plants, is it. Means energy demand has increased. Then what is the global impact of power consumption, is it, or power generation. Energy need for the human beings is increasing day by day, and because of the energy provides comforts of the modern life, so the transport and modernization of agriculture are putting a very heavy demand on energy consumption, is it. So because of this heavy demand on the limited sources, the price of the energy sources is steadily increasing. So this indiscriminate the use of energy resources on one hand and is leading to the energy crisis, and on the other hand to global pollution of air and water, is it. And unless some clean and cheap sources of energy are developed, this energy crisis leads to continue, and this may lead to the tension of war between the countries, is it, so which have a large resources of energy and by the ones who do not have these resources, is it. So that is the global impact of the power generation, is it. Then we have the impact of energy consumption on environment. Impact of solar energy. Solar energy is the cleanest form of energy. It causes absolutely no environmental pollution, and its use should be encouraged by all the governments of the world, is it. That is the impact of solar energy. Impact of wind energy. Wind energy is also cleanest form of energy, and it causes absolutely no environmental pollution. Its use should be encouraged in those parts of the world where the wind flows strongly, is it. Impact of the hydro energy. Hydro energy is in the way very clean, is it? However, the dams are constructed over a big river and a vast area behind the dam gets submerged in the water. So this is not only cause the dislocation of the population in those areas, but also upset the ecological balance, is it? So thus the hydro energy does cause environmental problems which must be addressed before constructing a dam, is it? Then we have the last impact of the fossil energy. Coal and natural gas are the fossil fuels used for producing electricity. However, burning of fossil fuels produces an enormous amount of ash and smoke in addition of the gases like sulfur dioxide and carbon dioxide, is it? So all these substances are causing the atmospheric pollution. So appropriate measures should be taken in the burning of fossil fuels so that the pollution of the atmosphere is minimized, is it? So this was all about this complete chapter. So with this we have finished this chapter. Thank you.